Oh yes, sir. Yeah. At a speed, revise the whole technical drawing to get through with this. But this will help you. Heaping nut. Based on what I'm seeing. So I'm just going to speed through different points that you should know for this exam. Why is in the chat if you've seen it? Share it with somebody, close off the live chat, press like, ting, let me get this thing on the road. Shucks. What's my first question again? Right, so you should know how to find, if you have a circle and we give you this arrangement, a triangle inside the circle. How do you find the center of the circle here? How do you find the center of the circle here? You should know that. So answer me very quickly, or I would just be speeded through because I want to sleep. You bisect the chords. These individual things here are chords. Bisect chords. That's one. How to construct a hexagon. You should know all the ways to construct the hexagon. Name some ways to construct a hexagon. You all just keep putting things in the chat when you're seeing it, right? You could construct the hexagon given the diameter and the circumscribing circle. Write this down. If you trust this channel, write this down. You can construct a hexagon given the across flat dimension. We call it across flat, meaning you can construct a hexagon given that a regular hexagon. You can construct a hexagon given the drawing tangents on the circle with a 60 degrees set square. Three main ways to construct the hexagon, and there are other ways you can construct the hexagon as well, but know those three. Press like on the video, people. Press like on the video. Yo, this man need a little organized. People asking for the Cape chemistry. When it's integrated science, the Cape chemistry will just be too much for my weary soul. Next thing that you need to know, all of this is vital information. By the way, this is a cube. Since in my days they're asking you what this is. This is like the free question in tech. There's a cube, right? Yeah, so look out for a question asking that. They will also ask you what's the elevation of a shape similar to this. Like to ask this shape. I think you get to draw this shape. One of the first shapes they make you draw in school too. Like this. And then all this is my ripped from tech notes. So like if you're watching it here, what you're going to see, you'll get all kind of ridiculous things, but you know. Anyway, let me draw it a little neat. You all understand what I'm showing you here? That's not good enough. If you're watching from here, you expect to see directly from that view, you expect to see this. Why is in the chat if you all understand everything so far? I just speeding through. It has some really important stuff coming up. Where would you use scales? Which one of these trees here where you do scales? Would you use, if you're doing any reduction, if you're doing an enlargement, if you're doing a freehand, which one you will not use scales in? This is the odd one out. So that is something you need to know. Anytime you want to make an ellipse, No. Constructing is constructing ellipse. Constructing an isometric circle was the first step. There's a lot of first step questions for technical drawing. Like constructing this was the first step. Constructing an isometric circle was the first step you had to do. I forget the exact thing. The first step you had to do is draw the isometric square. Draw the isometric square. Rate how much you know out 10 out of 10 if you knew all these things. Rate it out of 10. How much things you know so far. If you need to draw irregular curves, what will you use? If you need to draw circles, what will you use? What do you use to measure angles? Those are three things you need to know. What do you use to measure angles? If you need to draw circles, and if you need to draw irregular curves, what do we use? This one, flexi curve. This one, measure angles protractor. I mean, you can't be doing tech and don't know protractor and compass for this, right? Next up, there's a question. I just had the drawing for this though. I think they give you two circles like this. Two circles like that. Those are two circles with center points, people. Yep, believe it or not, these are two circles with center points. And you come the construction like this. By the way, I do this like around 15 years ago, and the last time I do some of this stuff was my first and second year in mechanical engineering. That. And what it is you're trying to find, boy, but I know the thing is center of the tangential. I'll help me there. What it is you're trying to find? Which one is the center of the arc? Is it A, B, C, or I think there's some point here or something, D? Which one is the center of the arc? The arc that is tangential with the two circles. Oh, so they're supposed to be touching this circle. Which one is the center of the arc that is tangential with the two circles? Obviously, in this case, is C, right? Wherever the points is they have. So you find the center of the arc tangential with the two circles. Why is in the chat if you know that? Yeah, we get some likes now, people. Wait, it's still at 271 people right there. So glad to see you here. I thought people that go to sleep. There's also this popular thing. You have two lines and they will do all kind of simi-dimi. But if you want to draw two circles of equal area, two triangles of equal area, you just segue a triangle down the line. All these triangles have equal area. This is something that you need to know, guaranteed. Get some wise in the chat if you know that. You need to know your symbol for third angle projection. Drawing is kind of lame. Let me start over. Circle, circle, circle. And if you're seeing here, line like that, boom, bam, all of these supposed to be in the same color. Bam, 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 bam. Right, so what projection is this? What projection is this? That means you're seeing, that means is normally use this kind of thing to indicate what's really going on. It's like a cone like this. And you're seeing from here, direct. And you notice this is not a dotted line. So what projection is this? So hear me out. What integrated science? I didn't even see what time people say is integrated science. Integrated science is tomorrow. People that can't do integrated science if it's tomorrow. Sorry. and doing physics tomorrow. But if integrated science exam is tomorrow, can't do it. So this is third angle. You need to know your first angle as well. The first angle, this will be dotted, not so. If it's drawn like this. So that's third angle. Make sure you know that. I'm trying to say here. Or if you have to draw a triangle like this, and this angle is not 90. Let's say this angle is 75, this is 75, this is 100 millimeters, whatever, I don't care. What you need to draw this? Options, compass and protractor, ruler and protractor. The options is be really ridiculous when they ask you these kind of questions. Set square and protractor, or look at this one, compass or ruler and pencil. I don't know about you, but the one with the pencil looking good to me, right? Actually, you could construct 75 degrees. You could construct anything that is 15 degrees to go into it. You could construct it. Once 15 degrees could go into 75, you could construct a 15, you could construct a 30, you could construct a 45, you can all the way up 75. Alright, enough of that. What type of tangent is this, people? You need to know what type of tangent they call this between two circles. That's called an internal tangent. Go and learn your tangents, real tangents. Everything are tangents. Every single time you see tangents in the textbook, learn something like that. You need to know your types of pyramid. You need to know your types of pyramid. This is a right triangular pyramid. So that is the one I had, and there's another one that you should know that you know they love. CSEC love hexagons and they love trapeziums. They love it. Somebody in CSEC must see a trapezium all over the room and just bring it home and just pet a trapezium or something, and they love hexagons. So just make sure you know everything where those shapes are concerned. So obviously a hexagonal based pyramid. Make sure you know that solely as well. Hexagonal based pyramid. You need to know your developments. What happens in terms of developments? What is a development, people? What is the definition of a development? Yeah, so this is an internal angle. What's a definition for development? Anyway, you need to know like how you develop a cube that's empty. How much size it look like if no, not a cube that's empty. A cube without a top. So if you're developing a cube without a top, how much sides you expect to see? How much squares you expect to see? There's basically nets from primary school, people, but just we don't use that word nets because you know we understand brighter. So a cube, you know, just no top there, a cube without a top. How much squares you will see? You'll see 5 squares, missing 1 square, missing the top. I know something like that is a question. Also, how you develop a square-based pyramid. A square-based pyramid. So like you have this pyramid here. Any pyramid, as a matter of fact, try and figure out how you, all of them is the base, and then is the triangular thing going up so in the air like that. So that's the development. Oh, good thing I tell you here, good thing. Take it down. Make your notes, think, pow. So tomorrow, when I get the question, so yes, boss. I just want to hear. Alright, you need to know your scales. Like if they give you a scale of 1 to 100, right? And they tell you the side on the object is 2000 millimeters. What would be the side on the image? So object, object, image, divide, right? Divide that, so 1, 2, 1, 2. So the side on the image will be 20 millimeters. So if they give you the object side, whatever number they give you, using the scale, you divide. Now if they give you the image side, You have to multiply using the scale. That's given that the scale is 1 to 100. If the scale was like 2 to 100, you need to change it to 1 to 50 then. But just make sure you know your scales. Make sure you know to go from like the object distance to the image distance. Nice, nice. How much people we have? We have 313 viewers. You all close the live chat. Press like on the video. Open back up the live chat. Let me keep the thing nice. As I said, they love trapeziums. Make sure you know what indeed is a trapezium. In technical drawing, they normally indicate the parallel sides like that. Trying to kill a mosquito for so long. Alright, so trapezium indicates the parallel sides. Know how your hexagon is. Look, know the 3 ways to construct a hexagon. Know the difference between bisecting a line and bisecting an angle. If we bisecting a line, we have the 2 points. Whap. They love this. They love this. Bisect your line. Right? Whap. Whap. These arcs are the same. So like this, I don't know how this, I know it's like, I don't know how this indicate that the axis is the same. But you can identify bisecting a line, and you can identify if you have an angle, how you're going to bisect the angle, right? You're going to come here, whap, 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 bring that down the center, so bisecting the angle. Know those 2 things. Know those 2 things. Know the construction of a perpendicular, how to make a perpendicular line given a point outside the line and given a point on the line. So, perpendicular line. Now these tips are given you based on what normally CSEC likes to test, based on what I know from my experience. And I also know that technical drawing is one of those, at least back in the days, that had a really small database, bank of questions. So when your teacher go through questions to revise some multiple choice and them kind of thing, and your teacher know what they're talking about, you're good to go. I don't know if they increase or if they're bringing more stuff with AutoCAD and thing. I'm not too familiar in that. So they get in what I'm familiar with, and then I could check them other stuff, right? Perpendicular line, how to construct a perpendicular line. This is normally be it. Like if you have a point on the line, outside the line, right? A point outside the line, you'd see this kind of construction. You draw that angle, and you come here and you do so whap whap, meaning right. Just now, you have the line, you have the point, like you say the point there, P, and you want to construct a perpendicular line going up to P. You draw your arc from P down, so you come so and say, yo, as a boss, arc from P, stick your compass there, next arc, same length, next arc, construct down, that's a perpendicular. As if the point outside line. If the point in on the line like this, P here, then you would expect to draw the arc right here, so then you come up here, almost like you're constructing at 90 degrees. Something like that, you could see something like that being done. Why is in the chat if you understand those? No, this is way faster. What I'm doing here with all is way faster. I know I'm doing it. People just think I don't know how to do it. I know I do it. What I'm doing here, faster. I'm not doing past paper questions because I'm giving you a whole heap of information at one time. You know, with math and thing I'm working through the questions because that's better for maths. With some subjects I'm working through. You know, this is why I do Geo. Who was here for the Geo live? I work through questions, I give you something like this, things to revise for, because I could pour out more information on you like this. Trust me on that one. Why is in the chat? The perpendicular construction point outside the line, perpendicular construction point on the line. I am actually telling you all ways that we use, I call it myself a top student, to study these topics, and we do every single thing in drawing. I always get A, full marks, technical drawing, mechanical engineering drawing 1, mechanical engineering drawing 2, and what things, development, unfolding of surfaces. Make sure you know the meaning of development. Just them 3 words, people. Unfolding, that just songing sweet in my mind. Unfolding of, good thing, I take in that, but I gotta finish this live. So unfolding of surfaces. Oh God, my God, paint in front of face. Also this shape, we love this shape, people. They will either give you the shape I'm about to draw, they will either give you the isometric and actually orthographic, or the orthographic and actually isometric. What is a cutting plane? Just when you cut the somebody answer this person, is a cutting plane. Yeah, so this shape how we used to do it like that. Pop. No, dotted, and then alright. Give me like 1 minute. I know we're speeding, but I'm trying to draw it a little neater. I'm still gonna go freehand though. Maybe I'll just do a little bit of guides. So wap, dotted. All you know the shape? I feel like your teacher would have given you a shape as well. And then there's do acting so thing, dotted, circle. Center line going up there. Yeah, when you cut the drawing to reveal a section, I couldn't resist. Me eat for the afternoon? Did I eat for the day? I eat for the day? Alright, so they'll give you this and ask you to draw. I cannot slow down. They'll give you this and ask you to draw not to draw, to pick which one. So they'll give you all kind of ridiculousness, and the correct thing is obviously something like maybe you might see down there too. So this is the correct thing. But they will give you all kind of ridiculous. So they will either give you this and ask you which one is the correct one, or like they might give you a shape like this and ask you to pick the correct 3D out of them. We want past papers. Triangle of 200 millimeters. I just had to believe on this. Triangle of 200 millimeters, shortest sides. So they'll give you a triangle and maybe perimeter 200, and then they give you the ratio of the sides 2, 3, 4, and I say what's the length of the shortest side. What is the length of the shortest side? 1. I can't do past papers on this channel. The last time I do past papers on this channel, I get a call from the head of the Ministry of Education, school supervisors, head of some security in the Ministry of Education. I get called from real people, principal, supervisor, everybody. So, can't do past papers. However, I help people in I literally bring you on the doorstep to what I can do, right? I go into the end toe of towing the line. So I'm not going to do past papers. Those who shouted me want past papers. What I'm doing here may be even better. You have to believe me. I'm giving you the exact things that you need. The exact things that you need to know for the exam that's coming tomorrow. If you want some more solution sheets and stuff like that, go on the Student Hub. In the meanwhile, let me just finish this. I'm nearly halfway done. Triangle of why after all people don't trust you, right? Triangle of 200 millimeters, shortest side. What's the answer? Over 34. Like, yeah, they may not ask you the exact answer. Somebody says something ridiculous. I hope I had the right person. They may not ask you the exact answer. They might ask you whether it's higher than this number or lower than that number. But the way to figure it out, add up all of this, get 9, divide this by 9. Well, and the shortest side is 2 times 9. So 9 into that, 30 something, 30. You'll get the gist of it. So once you divide this by 9, you get in like the idea. Do you get to use calculators for this? You get in the idea of where this will go. If they want you to find the exact value, you'll be able to figure it out really easy. So this is ratios from maths. Add up these sides, divide by the total, multiply by how much you get. Alright. 2 and 3, 2 nines of 200. 2 nines of 200. So they're saying 44 or something like that. I don't really know. You could use a calculator. Yeah, and I'll show you how to do that. You have to bring different numbers or kind of thing you can do it. What I'm about to do here, for sure something like this is coming. Maybe 2 or 3 times in the paper they'll bring something involving this. Sometimes it's not the answer, but they'll bring something involving this. So let me say you're putting your ratio. What is it I'm doing here? What? Oh no, it will be drawn like this. What is it that I'm doing here? This technique is what? Now this should be 9 divisions here, right? So you measure out 9 divisions going here. Actually, that is a question. Like, what is the first step when dividing this line? What is the first step? And the first step is writing out how much divisions you need. What is this? 12? 4 and 3, 7, 9. Alright, so 12. So the first step is dividing. Dividing is C. This one, not this one. Like if they put 72, or if they put a number that can like divide by 36, you can still, if you're constructing, you're dividing the line that you put in. Dividing AC by into 12 parts. Nice. How much more pages are the book? Ooh, I still have real pages to go. Actually, I nearly done it. If you want to create a tangent from here, what's the first step? What is the development of a truncated square prism? This brings real ridiculousness. So a truncated square rectangle, truncated square prism, truncated square, truncated triangular prism. What is the development? It will always look something like this. You know, with one piece showing that it cut off. Never will it look something like a disjointed piece like this. You know? So you would not see disjointed pieces like this, where you have a big drop there. No, everything must flow continual like that. Truncated square prism. The first step is connect the midpoints to the point P. Very good. When you're trying to create a tangent. Orthographic. Know that. Don't go and put this here. Well, it's not to put it. Don't choose one with this over here or any other kind of weird arrangement. You know your arrangement is normally like this. When we say front plan N, you know your arrangement is normally like this. Arrangement like that for the question. Another popular shape. What is actually the shape, right? What is actually the shape, right? Which one is that side? Which one is that elevation? I should have hidden lines on it. This has no hidden lines. This one has no hidden lines. Take a look at what I draw here. I just draw the shape. This is the next popular shape. A step. So watching here, watching here, watching here. What's the hidden lines? Where the hidden lines at? And I watch in here, so I draw I draw there. Anyhow, I know some people staying quiet and taking it. Some people just asking some really ridiculous questions though. Oh, you know the shape. Why isn't in the chat if you ever see the shape before? I no line here. And will it have a circle? No, the circle will always be here. Yeah. And they will ask you which one. So it's like a kind of weird toilet, but the circle up here, it's nothing down there. They'll ask you which one of the elevations or something is it. Or you have this line showing here. Have nothing here. Just, you don't want anything to have like a whole box here, because you're seeing this is missing this part. So this is missing a part right here. So you don't want that. So like if it's the front they give you, the front would look like this. If it's this, if you're watching from here. If you're looking from this direction, you expect to see nice. I like the Y's. This. That. All of my drawings are a little whack. Don't be too hard on yourself, sir. Dotted lines here, because there's your center going down there. There's your cutaway going down there. And a straight thing, so. Yeah, this is like you've seen from this direction. Any other thing is foolishness. If you're seeing dotted lines here, I think foolishness. If you see them, I don't know what other thing is bring. Or like if they bring a top projection, a top, and they're showing you dotted lines through the whole thing. This circle tell you he going down here? No. So what I just learn off what I showed you. Make sure you understand how to get those things. How to draw the normal and tangent on an ellipse. What is the next thing going? I think it's something like this. That. Normal tangent on an ellipse, make sure you know that. Question with directrix and ratios. I come into that. You see, people know what they're talking about here. I know there's a question that like the common directrix and ratio. I'm going to show you all of that. Only just stay watching. Good things happening here. So normal tangent. This is how you draw that. Two ways to construct a ellipse using the Trammell method. Research that. The Trammell method with this thing. Some kind of I forget how it's it. Let me just check it. Trammell ellipse. Right, it's be sometimes it's cut out a piece of paper. Anyhow, remember you just looking to be able to identify it, right? So if you see something like this, liming on top of an ellipse, Trammell method. If you see a rectangle and you're seeing your lines pulling the rectangle, however, I kind of forget the rectangle method too. Let me just take a quick peep. Yeah, I'm going good. But my lines pulled from the wrong side. The rectangle method. If you see that, or down. Bring a cup. Put my cup down. Put my cup down. What is really see going on here, man? So rectangle method, Trammell method. Memorize that. There we go. Wow. Let's just hide this user. I mean, just take a peek. People saying all kind of wines out here, boy. So make sure you can identify. That's the thing about multiple choice. You're watching to make sure you can identify stuff. So right, we have the first angle and we have the third angle. Just to test you on this again. If you're seeing this, these two should be the same level. Excuse me, what angle projection is that? In oblique progression, correct me if I'm wrong, you will be like this. Flat, then you have the angle here, let me say 45. And I think this will be half length. So like if this length was, if it's a square, if this is 40, when you drawing this at 20. Why isn't the chat if you're good with that? So this is the first angle because you're watching from here and it's popping out over here. In the third angle, if you're watching from here, this whole thing would be across here. I drew the third angle before, so if you just touch on, I drew the third angle before. Right? So first angle, third angle, know them. I think since 2005 they asked about first angle and everything. So look out for that tomorrow, right? Good. Next up. Alright, they like to ask about the area of a triangle, but they will not ask you directly what is the area of a triangle. They're going to bring all kind of weird shapes. Popular shape that students must know is this one. And let me just create some labels here. Tell me how you'd find the area of this triangle. A, B, C, the area of this entire shape actually. It's not, or they give you answers in the to pick from. So they're not going to say EB by AC. A, B, C, D, boy. Already going here. E, there. Those who was in the live before know that I'm a last of the last year, right? So A, B, C, D, E, F, right? So you will see your answer highlighting base by height for each triangle. So what you're looking out for is something like this by this divided by 2. So AC by ED divided by 2 plus AC by FB, that height over there, divided by 2. As in the chat if you understand that. So look out for these kind of weird things where you need to figure out the base and the height of the triangle. Nice. You all can answer the questions people ask in the comments there too. But I go in now over here now. First, what's the first step in constructing pictorial shapes? As I say, other first steps, when you're watching through your textbook, your notes, make notes of your first steps and your methods. What's the first step in doing that? What's the first step in constructing the ellipse? What's the first step? Right? Make sure you know that. What's the first step in constructing pictorial shapes? You need to know everything that happens when you cut a cone. All the different ways to cut a cone will result in a different shape. So you need to know, yeah Kevin, I come into that, you need to know all the ways, all that will happen when you cut a cone, all the things that will happen when you cut a cone. If you cut the cone straight down like this shape that you see there, like when you bring it out, yeah, turn it so. A shape that you see there, hyperbola. If you cut it like this, what's that shape? Parabola. If it comes off of the base and cuts like this at an angle, ellipse. If it cuts straight, horizontal keyword, circle. So So the first thing I'm going to do is draw a box. Very good. Draw a box. Right, so hyperbola, parabola, ellipse, circle. I hope I'm correct about these two. Just verify. Your knowledge a little rusty, but I know my thing. So I think it's hyperbola, parabola, ellipse, circle. I'm sure about these two. Right? I think I'm sure about these two as well. So you need to know this. They can ask you different way, things that will pop out when you cut the circle. Nice. It has something that is asked. I just have it here: drawing or making a triangle equal to making. I'll let you research this. Making a triangle that's equal to a polygon. They like to ask you to identify something with that. Making a triangle equal to a polygon. Making a triangle that's equal to a given polygon. Yes, get some kind of weird sketchouts. Like if this was a polygon, you'll see some kind of weird sketch like that or something. Look out for that. Sometimes this could be a straight angle, or like if you had, I forget it. Just look up. This is something I kind of forget. Research that. Remember, I just get like 15 to 20 minutes. No, I had a meeting that finished 9:30 thereabouts, and I had that time 30 minutes to prepare to rush down some tea for y'all because I wasn't ready. Anyhow, so yeah. So I didn't get time to research this part. Good. I just know that I need to know the drawing for making a triangle that's equal to the area of a polygon. You can look it up on YouTube if you don't have any notes. This ratio of small square to big square. Ratio of small square to big square in a scenario like this is always 1 to 2. Right? The ratio of the small square to the big square in a scenario like this is always 1 to 2. Know that. Always, like you have a bicycle, Fred is on a bicycle, he run into a nail. What would be the shape if this move along like that? Oh, you need to know all these shapes. You need to know involutes, how that come about, parabola already tell you about cutting the thing, and the Archimedes spirals. This one though, remember he moving and is circling at the same time. So the shape that is here is a shape something like this. And what is that shape called? A cycloid. Why isn't it chat if you're with me, if you're understanding all these things, you know how to revise? Y'all are nearly finished. Stay true, holy faith. There's 3 or 4 more pages to go. Things to remember. Right? Hold it. Where's the time? 11 o'clock. 11 o'clock, man. Let me go to 11:30 and then tell me you're tired now, man. And then wake up in the morning and take it through. Alright, so sometimes they'll bring a shape. What is this popular shape? The little block. So I'm going to use this one. I don't want to keep drawing an extra line there for. Right, and they will actually draw planes for the projection. It'll be real interesting. They'll draw planes, like a plane up here, and they will draw the projection on top. And they'll ask which one is like the front end projection, end projection. You understand what's going on there? Maybe another plane in front here as well. So this look like this. So obviously plan your front, your end, elevation, whatever. So make sure you know inside out how to go from isometric to orthographic, orthographic to isometric planes, then have TD and add mass tomorrow, high pressure. How to go from a square to an octagon, to the biggest octagon inside the square? What you need is, you can do it to a set square. Octagon, right? You can do it to a set square and a divider or a compass. I think easy with divider. Set square and divider. Next. Construct a triangle using perimeter and ratio of sides. How do you construct a triangle using the perimeter and the ratio of the sides? You'll hit out the whole perimeter of the triangle. You draw the ratio of your sides. You draw the thing now. So you create the ratio of the sides. Whap, swap, whap. Whatever the ratio of the sides was. Yeah, that's the base of your triangle there. Compass this up so. Compass this up so. Compass this so. Where the two intersect. Bam. So this is how you draw a triangle using perimeter and ratio of the sides. Make sure you know that. Make sure you know all the different tricks and things for the drawing triangle. Perimeter of rhombus. Or shapes. Just make sure you know shapes all together. I had this one, perimeter of the rhombus. Perimeter of a rhombus is equal. Know what's the difference between a rhombus, kite, and square? All them four-sided figures. Just go and learn all the four-sided figures. Parallelogram, trapezium, rhombus, square. Learn all the effects that make them. And that your rhombus. So like you see the rhombus was 200 in the perimeter. Then the side, since all sides in a rhombus is equal, the side will be 50. If the rhombus was 152, what would one side be? And secondly checked. Dimension, know all your dimension conventions, how to properly dimension something, especially diameters and things, boy, or radius. Like if you have R15, R5, this is always capital. The letter is always before the number. Letter before number, that capital. Nice. How to bisect a line with a ratio, we talked about everything already. So here we come to the directrix. What's the directrix? I'm trying to draw a straight line, bro. If you're using a hyperbola, parabola, hyperbola, focal, if you draw like, if it go like here to there, and they say the eccentricity, the ratio, eccentricity is like 3 to 2. And using 30 here, or 60 here, or whatever number here. This is the first number, this is the second number. So this will have to be 20. 3 to 2. That's what they mean. Common kind of question to ask. Why is in the chat if you're understanding this? Alright, rate how much we learned so far out of 10. Enlarging, making a shape bigger. You see you have this shape and you need to make it bigger. Same thing, lengthen it out, create your scale, and you make that bigger, my friend. You make that bigger. Whether it was that or a whatever kind of shape it was. Just organize up one side. Then you know how to proceed. Alright, I run out of space. But you catch the vibe. So make sure you can identify that how to enlarge in a shape. If you have, I'm too sure about this one, I'll help me with this one. If you have, what are you giving? Not too sure what this question, and I'm even too sure how to ask this question. If the tell me if this is a question. I just seen it here now. I don't know if this is a question. If you have a hexagon on the outside of the circle inscribed, and like, let me say, now this side to be like 21. What will be the diameter here? Just check this. You ever seen that before? $42. Or you have this situation, or you can do it the other way around. I want to say this. You're given the circle, and the circle is diameter 42, and you have to draw a hexagon and circumscribe in the circle. What will be the length of one side? Now I use maths to try and figure this out. 1, 2, 3, 4, 5, 6, right? So I'd be like, I'm not too sure with this. Or let me just look up this and verify this. The chat saying 42 to 21. So I'd be like that. So it is sus. If it's on the inside, it's good. If it's on the inside, I think it's so. Just there's two things you need to check, whether it's the circle is on the outside or the circle on the inside. If the circle on the inside, then I think it divides like 41, like 42-21. Because if the circle on the inside, well then you could say now. You can say confidently that this plus this is 42 and 21, 21, 21. You catch what I'm saying? But if the circle is on the inside, so just check over that. I know you need to know this, whether the circle is on the inside or outside. How does the side of the hexagon relate to that? So just double check that in your notes. How to construct a hexagon given the length of a side. No, given the circle and the length of a side. It is. Wow. Wow. And then you just come here and you cut the rest. 1, 2, 3, 4, 5, 6. So it won't be so much cutting, it'll just be one more. Just be two more. So yeah, you all see now the points to review with hexagon. It's supposed to be outside, that's the one. Nice, nice, nice. Across the flats versus across the corners. Nice. I'll pay attention to the chat. I'm talking good things there. You need to know what you're doing when you're doing this. What are you doing when you're doing that? What's the first step in drawing a spiral? Try a circle, divide into equal parts, and then start a long stupid game. I can't remember the whole spiral game, but you draw a circle, divide it into equal parts. It's about, it has some other notes here too. Let us see, talk about that. This one, they'll ask you some special drawing shapes now. BAP, what are you doing here? This is when you're given the hypotenuse. and an angle. Constructing a triangle, giving the hypotenuse and an angle, right? Nice, 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 nice. If you have a square and you know the length of one diagonal, like it's 68, what's going to be this side? The answer is like 68 divided by root 2. Approximately. So approximately 32. And any other notes I have here, boy? All that's what I have for my notes there, how long we take. Check exactly how that's what I wanted to take. Very nice. Check the Discord. Y'all put the link in the Discord. I'm going to close off the live now. Y'all can run to Discord if you all have any more stuff to do. I may not be on Discord. I might just pop in. This, I think, may be like about 60, 70, 80% of revision kind of covered there. Head to Discord to get the rest of questions, rest of answers you could look at. All the best. Sorry I couldn't spend more time going through and going through everything in detail in technical drawing. I had to do like a rush study this quick session. But it is what it is. I am only one person. All these subjects is Discord link. Let me send the Discord link. And I still have physics to do tomorrow. For the physics people, that's going to be a little tiring. Alright, so hang on there. Let me just send the Discord link. Close the live. Press like on the video if you haven't yet. I'm trying to send the Discord link, boys. I'm trying to send the Discord link there, boy. Bless up. Remember what I tell you to revise some of the topics I didn't give you all like answers up per se for. But good things. Good things was displayed. This link that I'm sharing here only have 24 hours, so make sure you click that link now. Woo! The Student Hub is alive with the sound of music. Technical drawing. Look at people paging me. Nice, nice, nice. I'm loving it. Zip, 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 zip. So y'all can head to the Student Hub. If you don't know how to use Discord and like the first time using Discord, I'm sorry for you. You take a little 15-20 minutes to just understand how to get to the CSEC technical drawing channel. But once you're inside, nice. Only bring on them ones, make me proud, love and blessings. I already say the prayer. I could go back and watch the prayer for at the end of the admin stream and say amen. And we can see. We can say it now, people. Let me see if there's anything here. AutoCAD, yeah, hard luck. I didn't do AutoCAD until engineering, and I don't want to get engineering AutoCAD. So I need to go back and learn what they want you to do for CSEC in AutoCAD for paper one. But you can